is the exact point. I need you to focus on this place, no side talks, and let me know if I make any mistakes. Okay? So let's look at the second one. From the table, what do we have? Uh-oh, you can see it.
Yeah.
Okay, just trust what I say.
Okay.
Do you trust me? Maybe
No,
not.
not really.
Alright, so look at it here. What do we have? -1 and 0. That should be easy.
Yeah.
When x is -1, y is 0, so it doesn't need to be here. Okay?
Yes.
And the next one, when x is -0.5, y is 2.75. -0.5 is here. 2.75. This is 3.
Yeah.
This is 2. This is 2.2, 2.4, 2.6, 2.8. So 2.75 is in between. Agree?
Yeah.
So in between these two. Here and so this is 2, 2.2, 2.4, 2.6, 2.8. 2.75 can actually be rounded to 2.8 because in between is 2.7.
Mr. General,
Yeah? Is there a problem?
the answer should actually be 2.37.
Yeah.
I love it. I love it.
2.375. Alright, it's okay. So that will be 2.4 approximately, right? So we use 2.4, but you write 2.375 in the table.
Yeah.
Okay.
So minus 0.5 and 2.4. 2.2, 2.4, that will be here. Do you agree?
Yes.
At this point. And the next one, 0 and 4. That's easy. Okay?
Yeah.
The next one is 0.5 and 5.6. 0.5 and 5.6. 0.5, 5.6. This is 4. This is 5, right?
Yeah.
5.6 will be 1, 2, 3. Here. Do you agree?
Yeah.
Okay? The next one will be 1 and 8. Let's see. 1, 8. Easy. That's easy one, right?
Yeah.
And the last one will be 1.5 and 11.9. 1.5, 11.9 will be very close to 12.
We can't see.
Oh, oops, sorry. You see that?
Yeah.
Okay, so here is 10, here is 11, this is 12, this is 11.8, 11.9 is in between like that. Okay, so the line is definitely not a straight line. It shouldn't be.
Should be.
Shouldn't be. So, one thing I have noticed about your situation with IGCSE is that you're not allowed to use French curve.
What?
The French curve is it's like all these curve sets you have in your, it's like all your set square, you like a triangle you have in your math set, but it's in a curve form. So you use that to draw curves by tracing at least 3 points together. But it looks like IGCSE wants you to just trace it out yourself, which to me, yeah, by hand.
Okay.
So sorry about that. I feel bad for you.
It should be French.
So you have to try to know what it. So I'm just going to try to trace it by hand. Maybe I use a pencil first, because once I do that, everything will be messy. So if you look at it, the shape will go like this. Then it's going to turn and go up like that. Okay? Right, so let's try. This is the time you don't talk to anybody. If anybody calls your name, just ignore them.
It's very dangerous.
Yeah, it's dangerous. It's like holding, it's like you're building a bomb and someone is trying to talk to you. You might just explode too. So let's pretend that is the line.
That's a very good line.
Yeah, I know, you're being sarcastic. Thank you very
I'm
much.
not being sarcastic, that's a very good line.
Alright, so that's my line. Can somebody tell me what a normal cubic line, a normal cubic equation should look like?
Equation?
Yeah, cubic line. This is quadratic, right? What should cubic look like? What are the...
Like this.
Say that again. Show me that. Yeah, should have something like this. Or something like this.
Yeah.
Okay? But one of the reasons we probably wouldn't experience that here is because we're not extending beyond 1.5. Maybe when we extend before 1.5 or above 1.5, then we can have that shape. But a cubic line should have 2 turning points. Okay?
Okay.
But here we can't even see 1 turning point. That's because of the range.
Okay.
Alright? Quickly. So we have drawn that. Show that the values of x where the two curves intersect are the solution of this problem. Now this is one area I need to show us something. What is the equation of the first part? Elsie, the lights, please. Answer, please. Please. When I need you to say something, I will call you. Otherwise, please. You can reason along. I'm ready for the questions. So the first line has this equation. Y equals 10 minus 8x squared. The first curve the second one has this equation. X cubed plus 3x plus 4. Now, the question we're trying to solve here is saying, show that, can you just see a little? Just a little. Alright. Show that the values of x, maybe you turn off the one in front. That's the one in front.
Can't see anything.
Okay. Is it better? Just a little. Because I need us to see this board. Not the one at the back. It should be the one in front. Yeah, I think it's better. Look at it. Show that the values of x where the two intersect. Have you solved problem with graph in Form 2 where you find solution by looking for where they intersect? Isaac? Something about intersect. What do you do when they intersect? You solve simultaneously. So basically we are trying to solve these two simultaneously. But remember, we cannot subtract coefficient to do simultaneous equation, right? What would you say if I tell you to solve this equation simultaneously? What's the first thing that comes to your mind?
Graph.
No, forget about graph. I'm talking about, we're doing graph already. What is the first thing that comes to your mind if you are to solve this equation simultaneously? Okay, maybe I give you a simpler equation. Y equals 3x minus 1, y equals 2x plus 4.
Make the x the same.
Makes the x the same. Okay, but unfortunately you can't do that here. If you don't want to make the x the same coefficient, what can you do?
Makes the y the same.
Okay, that's one. With y are the same already. You were saying something? Substitute what? That's the key. Substitute what? How can you use substitute in this problem?
Well, the second one, the first one.
What?
First one, the second one.
No, I'm asking you. It depends on whatever you want to do.
The main one.
No, this one. Because whatever you say here, we can use here.
It doesn't matter.
Now, how can you use substitute is my question. Yes?
You plug one equation into the other one.
How do we do that? Tell me.
Just y is equal to that first equation, so
Mhm.
you can just put that first equation into equal to the
So
other.
tell me what to write. Listen to this, please.
10 minus 8x
Yeah?
squared.
What do you see
for
10?
that one? Okay, then that's 3x
Uh-huh.
minus 1. What is that? 1?
Mhm.
Yeah, equals to 2x and then that.
Can you see that?
Yeah.
Okay? So that's exactly what you do here. If you are trying to solve these two equations, it means you are equating them together because this is y and this is y. And if you are trying to solve them simultaneously, this y should be the same. If these y's are the same, then these two must be the same as well. Do you understand? It's like saying A is equal to B. The same A is equal to 7. What can you say about B and 7? They are equal. So if y is equal to this and y is equal to this, what does that tell us? 10 minus 8x squared must be equal to what? X squared plus 3x cubed plus 3x plus 4. Does this make sense? So this is what we simplify. If you simplify now, this is negative x cubed minus 8x squared, negative 3x plus 10 minus 4. Okay? Negative x cubed minus 8x squared, negative 3x plus 6, right? But I want this to be positive because here it is positive. What do we do now? How do I simplify? How do I get that out? What do I do to remove this negative? What? Times everything. Negative 1 times everything, including 0. Right? With negative 1 times this, what do you get now? X cubed plus 8x squared plus 3x minus 6 equals 0. And this is the question they are asking you. Show that the values where these two intersect. When two curves intersect, it means you are solving the equation simultaneously. Have you done simultaneous equation by graph before? We tell you to plot one equation, then we tell you to plot another one, and wherever they intersect is the solution. Do you remember this from 1 from 2? That's exactly the idea here. Okay? Show that the values of x where they intersect are the solutions of this equation. So if they intersect, it means you solve this simultaneously. To solve this simultaneously means you equate the two functions. And what is simplified to is this cubic function, if you solve it, is exactly where these two meet. Am I making sense? So they are asking us to show that by equating here. Show that the values of x. They are not asking you for the values of x, guys. Show that the values of x, where these two intersect, are the solutions of this. Better still, let's go this way. Where are the values of x where they meet? Can you see the first one? Somewhere here, right? And the second one, somewhere here. Okay? So it all depends on how you draw your curve too. You have to be careful. Okay? So, let's see. For this one, what is x? Can anybody see? This one. What do you think x is there? Maybe I zoom it. What is x at that point? Come on, guys.
Negative 1.2.
Negative 1 point. Say that again.
Negative 1.
So I'll just trace it up like that.
Yeah,
Negative 1.2.
Yeah.
Yeah, negative 1.2. And this one, if I bring that down. So what's that? That's not negative.
No, that's positive. I'm saying
What do you mean? What is the x here? That's the second x, right? This is the second point where they meet. So what is x here? 0. This is 0.6. Let's say like 0.675. Okay? So this is about 0.675. And this is about negative 1 point what? 1.2, right? So let's see if they are indeed the solution of this equation. So let's substitute. Okay? Let's substitute. So the first one is negative 1.2, right?
Yeah.
So let's see, minus 1.2 cubed plus, of course, like this. 8 minus 1.2 squared. Can somebody press the calculator? 1.2 minus 6. What do we have? And the second one, you should have something close to 0. Otherwise, the other curve is not entirely right.
I got 0.192.
0.192. Yeah,
Yeah, that's 0.122.
good. So the second one is what?
Oh.
Minus 0.65, right? So let's test that too.
Minus?
Good. Plus 0.65 cubed, is that? Yes. Plus 8, 0.65 squared, plus 3, 0.65 minus 6. What do we get?
Negative 0.395.
Negative?
0.395.
Yeah. You all agree with Alex?
Yes.
Can somebody tell me why we didn't get this 0 back? Because what? The hand drawing graph will not be perfect. But if you get something like 1.7, then there's a problem. You understand? Here you substitute, you get 8.2. No way. You have to get something close to 0. Something approximately 0. Am I making sense?
Yeah.
Alright. So I will not expect when you do it you get the same values. Your answers must be different, should be different, because the way you sketch mine will be different from the way I sketch. I sketch yours is different from, you understand what I mean? I'm saying rubbish, I know. Okay, now this is another thing I like to call our attention to before I give you the paper to try. By drawing a suitable line, solve the equation. So sometimes they tell you to draw a suitable line to solve an equation. Before I do that, I give you different examples here. Then this will be easier to do. Are we ready? Guys, graph problems usually come in paper 4. Paper 4 is a 2.5-hour paper. And it's usually been a lot of marks have been allocated to it. Let's look at this for example. On the first page, there is no mark allocated. Please look. On the second page, can you count how many marks you can see here altogether?
3, 4.
Oh, that's not the first one.
14. 15.
Can you see this is what?
1,
1, 3, that's 4, 7, 7 plus 4, 11,
15.
12, 15. One question. So please, that's why you should take it seriously. Isaac is sleeping, someone is doing something else. You might not be in good mood, but you just have to take this topic seriously. That could be the difference between a C and an A. That's a lot of marks. And this is not an optional question exam. It's not like, oh, take any, choose any 3. No. Answer all. So if you leave any question undone, you just lose the 15 points. That 15 is a gap. It's a huge gap between maybe an A and a C. And all you have to do is just do graph work. It's not like you have to remember a particular formula. So I'm a bit concerned that a lot of us are just in that I'm not interested in work mode. There's a reason I delayed this topic to this moment. Because I wanted it to be on a Monday. So we need to snap out of whatever that is your problem. Joey, I need this part.
Okay. Already did.
Okay. I'll give you a question that is different from this one to explain the last thing that we're about to do. So forget about what we have here for now. Maybe part of the question, you have plotted the graph 1 equals x squared minus 5x plus 6. This is the first part of the graph. You have answered so many questions. You have done gradient. You have done all those other nonsense. Equation of line of symmetry. Suddenly, at the last part of the question, just like we're about to do, the question says, draw a suitable graph, suitable line, usually a line, most of the time. Draw a suitable line to solve the equation y equals, so maybe I write the instruction, then I will do different samples. Draw a suitable line to solve. So I do 2 examples. Y equals x squared plus 3x plus 1. Another one, draw a suitable line to solve the equation y equals, usually it should be equal to 0. X squared plus 3x plus 1 equals 0. X squared minus maybe x plus 9 equals 0. Could be anything. So these are the type of questions that I want to explain now. Please listen. What they wanted to do, this will definitely look like this. It's a minimum curve. Do you agree? Right?
Yeah.
So I put it in 2 ways for each of the questions. They wanted to draw a line like this, and the solution of the equation will be the solution of this one. Where they meet will be the solution of this one. Do you agree? Maybe this one will look like this. We don't know yet. But they will meet at 2 points. So the task is, how do we know what the line is if we don't know the equation of the line? Am I making sense? This question will definitely be related to this. The goal is, draw a line on that parabola that is already drawn for you. Where the 2 of them meet is the solution of this equation. Okay? To do that, you need to find a way to make sure the curve and a particular line will intersect. By intersect means you are solving them simultaneously. Am I okay with that? Are you okay with that? Where they meet is the simultaneous equation, right?
Yeah.
And what did we do at the beginning of the simultaneous equation just now? We substitute. By that substitute, what did we do exactly?
Join the two together. Yeah.
What do you mean join the 2? You equate the 2 functions. Is that not? You equate both of them and we form an equation. Hello? Melody, are you with us? Oh, sorry, sister. Are you with us? So you equate both of them. So you are reversing the process now, basically. After you equate both of them, this is what you get. So the problem is, what did we equate? One of them will be the curve, the other will be the line we don't know yet. I'm telling you the background so you can understand better what I'm about to do. Again, this equation is what you get after the curve that we know and the particular line meets. How did we get that in algebraic form? We equate their equations. Then we put it in a better form, just like I just did now, and we got this one. So now we are going to reverse the process. Now this is the way out. Compare these two. Look at what is familiar and what is not familiar. Whatever that is familiar, leave it on one side. What is not familiar, take it away. So tell me, look at this and this, what is familiar? What do they have in common?
X squared.
X squared. Can you say something, please? To everybody, what do they have in common?
X squared.
This and this. X squared. I leave x squared here. Do they have 3x plus 1 in common?
No.
Take it away. So it becomes minus 3x plus minus 1. Do you agree? Do you agree?
Yeah.
So now I'm having x squared. What do I need on this side to make it look like this? What do I need here? So my target is this, to have x squared minus 5x plus 6 equals ax plus b. This is my objective. This is my goal. So this means the curve and the line intersects. Are you getting what I'm saying now? If I can get this, it means the curve and a straight line, which is the line they are talking about, meet to form this equation. Okay? So the first thing is, I separate them. I can change this to actually minus 5x. The first thing is I separate them. I take that away. Then I look at it, oh, I need minus 5 and plus 6 here. And then I do it to both sides. X squared minus 5x plus 6. On the other side, minus 3x minus 1 minus 5x plus 6. I haven't changed anything. This and this. Any question? Yes? Yeah. Does this make sense so far? You don't get it? Okay. When I finish, I'll explain it. On this part, I have my x squared minus 5x plus 6. On the other part, I get minus 8x plus 5.
Yeah.
This is my curve. This is the suitable line they are talking about.
Yes.
It means the intersection of these two will produce this equation. It means if I can draw this line, wherever this line meets with this curve, those 2 points is the solution of this equation. If you understand this, raise your hand. Okay, I explain it again. With this one. Anika, please focus now. I go again. Let's start with this one. I want to find the solution of this by drawing a suitable line. Don't use the quadratic formula 0, because that's not what they're asked to do. Okay? You have to be able to bring out that line yourself. And we need to see that line on your axis also. But how do you draw a line if you don't know the equation of the line? It's impossible. Do you understand? So your goal is to find the equation of that line, which you will draw on your graph and be able to see where this line intersects with the curve. And that is the solution. So the first thing is, what is the equation of the line? If the line and the curve produce this, you need to find a way to separate them so that there's the curve on one part and there's this line on the other part. Because that is what it means. When two lines intersect, it means you are solving the equation simultaneously. When you solve the equation simultaneously, it means you equate their y's together and you simplify and solve. Do you understand? So we are trying to reverse the process. Somebody has done it. It has been mixed together, and somebody got this. But this mixture is when the person has equated x squared minus 5x plus 6 with a strange line. We don't know which line. It means at a point there was y equals x squared minus 5x plus 6, and also y equals maybe 3x plus 2, for example. Maybe I draw this line and this curve together and they meet at these 2 points. If I want to know these two, all I need to do is equate this one with 3x plus 2. Do you understand? If I want to know the solution of these two equations, I will equate these two together. Look at it. Y is this and y is this. That means this and this are equal. Okay? And that's what I've done here. Now if I simplify, I get x squared minus 8x plus 4. Do you agree? So the solution of this is actually where these two intersect on the graph. So I don't need to use formula method, factorization or whatever. I just need to look at the curve and see where both lines and curve meet. Usually 2 places. This will have been like this. This will be in this form. So these two on the x-axis will be the solution of this equation. That's what we are saying. But rather than giving you the equation, we are doing it in reverse. They are giving you this final output. They are telling you what and what were equated together. One of them is definitely the curve. The other is a line. The curve we know, but the line we don't know yet. That's what we are trying to find out.
Oh.
Does this make sense now? So to find out, I proposed it. There are other ways people do it. But this is how I did it and worked for me. I look at the equation of the line. I pick something that I need here. I can see x squared, but I don't need minus 5x. Right? And I don't need plus 6, kind of. So I leave this here. So I'll start the problem solving again. Yes, sir. Of course. I leave this here. So this is what I need.